Hello, everyone, and welcome to Calculus. The topic is implicit differentiation. What we've been doing so far has been explicit differentiation because y has been expressed explicitly in terms of x. Today, we will learn to solve problems that are not functions. That is, they do not pass the vertical line test. I did give a little summary, steps 1 through 4 here, but I'm just going to go ahead and do the first example, and I will follow those steps, but this way you have them in your notes. So you know what I'm going to do first. I'm going to make a graph. So you might recognize the square as meaning a parabola, but notice that the y is being squared and not the x. So that gives you a clue that it has some kind of parabolic form, but since the y is being squared, it's going to go left and right instead of up and down. So it's easier in this case to plug in numbers for y and get numbers for x. So when y is 1, 1 squared is 1. When y is negative 1, negative 1 squared is 1. When y is 2, x is 4. Do you recognize these numbers? 0, 0, 1, 1. But now 4, 2, not 2, 4, because the parabola is sideways. So this is not a function. So the thing is that there's not going to be a formula that says y prime is or f prime of x is with an x in it, because at a certain value of x, let's say when x is 2, the slope could be this, or at x is equal to 2, the slope could be that. So today we're going to do implicit differentiation, and our answers are going to have y's and x's in them, because you need to know the entire ordered pair to know which of these 2 points you're talking about. Just knowing the x value isn't enough. So the key is you just have to differentiate like you normally would. When you see a y squared, you're going to write it as 2y. But think about this. What do you normally write when you take the derivative of y? If you had y is equal to 3x squared, when you took the derivative of this side, wouldn't you write y prime or dy dx, right? So that's what you have to do. Even though you got to do the 2y, you still have to write y prime. You can't forget that step. You took the derivative of y, you need to write y prime just like you always would. And then for the x, you can do what you always would. The derivative of x is 1. No special attention needed. I'm trying to get the y prime all by itself. So I divide both sides by 2y. That's the derivative. So let's just give you some examples. If I wanted to know the derivative, which remember means the slope, if I wanted to know the derivative at x is equal to 1, right here, there's 2 different values. But at x is equal to 1, y is equal to 1. And the derivative at that point, y prime, is 1 over 2 times 1. So it's 1/2, which it looks like it could be 1/2. It's kind of a shallow slope. Let's do another one. If I want to know the derivative at x is equal to 4, it could be 2 different things. It could be this one or this one. I really need to know the y value. So at x is equal to 4, y is equal to either 2 or -2. The derivative at the point 4, 2 is going to be, use this formula, 1 over 2 times 2, 1/4, which makes sense. It got shallower, right, because it's flattening out. And at -2, so x is still 4, but now it's the point for -2, the slope is going to be -1/4, because I put a -2 into this formula that I have. So I'm plugging in y's instead of plugging in x's. And that's called implicit differentiation. Let's do another one. So the thing you have to remember is that x's are normal. Y's are now done like x's, but when you take the derivative of y, you have to add y prime is equal to the derivative of 25 is 0. It's a constant. So I'm going to subtract 2x from both sides. I keep my y prime here. I'm putting it in a different color for you to help you see it. And then last step, y prime is equal to negative 2x. I divide both sides by the 2y. Y prime is equal to negative x over y. And that's my answer. See, it has an x and a y in it. Does anybody remember what this graph looks like? Are you thinking about it before I just tell you? It is a circle of radius 5. So let's see if I can get my little circle tool here. Of course, it's going to show you if I made my 5 good or not. Not perfectly, but close enough. So this is a circle of radius 5. This is 5, 0. This is, I'm going to put a really big dot there so it can be 0, 5, 0, negative 5. Okay, so this, it doesn't have an x minus like 1 or something, so it hasn't been moved left or right. It's just on the center. A negative 5, 0. But what are some other points on this? So you don't have to actually be able to do this. I'll just tell you that 3, 4 is a point on the circle. 3, negative 4 is a point on the circle. What is the derivative right there? The derivative would be negative x over y. And that looks like it could be a slope of negative 3/4. Where this one, y prime, is still negative x over y, negative 3 over negative 4. And see how that came out positive? So these are really cool derivatives because they use both the x and the y coordinate to give you the derivative at a very specific point. Number 3, the Folium of Descartes is x cubed plus y cubed is equal to 9xy. So I would love to think that somebody would like to try this on their own. So I'm going to give you the answer in advance. Y prime is equal to 3y minus x squared over y squared minus 3x. And then find the slopes at these 2 points. The answers are 5/4. And at this point, the slope is 4/5. So if you got it right, just make sure you show all your work and you can move on. But for everybody else, I am going to do the problem out. So the Folium of Descartes is pretty cool looking. It comes down into quadrant 1. It makes a loop, and then it goes out like that. So the point 4, 2 is on there, and then 2, 4, and those are the slopes that I just found. Okay, so remember, x's are normal, 3x squared. Y's are now treated like x's, 3y squared. But whenever you take the derivative of the y, you write y prime. And just so you know, you've been doing that all the time. When you have y is equal to 2x to the 5th minus 3x squared plus 1, you've always been treating this like normal. The derivative of y to the 1st would just be 1. But then you've always written y prime, right? That's what you've written on this. Oops, I was writing y to the 1st. If y is equal to that, then y prime is just 1 y prime. And then the x's, you would do this. So this is the same thing. You're taking the derivative of the y, but you're writing y prime. Okay, the other side's really hard because most people don't see that you need product rule. So if you got this answer wrong and now you've come back to watch the video, you probably forgot product rule. So I'm going to stick the 9. I'm just not going to do the 9. I'm going to do it separate. So 9 times this little product. So the second times the derivative of the first plus the first times the derivative of the second, which I'm going to keep changing the color for you and hope that helps. That gives me 3x squared plus 3y squared y prime is equal to 9y plus 9xy prime. So just like in anything, you're going to get all the things with y primes on the same side. 3y squared y prime minus 9x y prime is equal to 9y minus 3x squared. I'm not showing you all the little algebraic steps anymore. You got to be able to do that on your own. But I've subtracted 9xy prime from both sides to move it over here, and I've subtracted 3x squared from both sides to move it over there. And now here's the key step. It is on that first page in your notes, is to factor out the y prime. That's how you get there just be one y prime in the problem. And now, because there's just one y prime, now I can divide both sides by 3y squared minus 9x, and I get y prime is equal to 9y minus 3x squared all over 3y squared minus 9x, which is not exactly how my answer looked. I did factor out the 3 because it made it a little tidier. I took the 3 out of the bottom as well. That way I could cancel it. You can't cancel the 9s. You can't cancel those 3s. They're parts of terms, but you can cancel. Now that I've factored it, you can do that. So my final answer, y prime, is 3y minus x squared over y squared minus 3x. Okay. And then the question was, what is the slope at 4, 2? So we did learn a notation for this. Normally we would write f prime of x, but in this case we need f prime of 4, 2. So it's a joint pair, but it's still assumed that x comes first and then y. So 3 times 2 minus 4 squared over 2 squared minus 3 times 4. So what is that? 6 minus 16 is negative 10 over 4 squared minus 12 is negative 8. So 5/4, which was the answer. This next one still uses implicit differentiation, but they've made it a little bit trickier by asking the question, show that the slope dy dx is defined at every point on the graph. That really usually confuses people. They're like, what does that even mean to be defined? But think about it. You did learn this. You know when the slope is undefined. So when is a slope undefined? When a line is vertical. So a vertical line is going to have an undefined slope. But what does that mean in terms of the actual slope value? It means that you were going along doing slope and you got 0 in the denominator. So maybe this was 3, 1, and maybe this was 3, negative 1. Well, we'll make it even negative 4, let's say. And then y2 minus y1. But on the bottom, see how it's 3 minus 3? A vertical line is going to have the same x coordinates. And so it's always going to make a 0 on the bottom. And that's your warning that the slope is undefined. So pretty much what this question is asking us is to show that the bottom is never going to be equal to 0. So let's do the implicit differentiation. The derivative of 2y is going to be 2. Because I'm doing a y, I have to write y prime, is equal to 2x. And the derivative of sine is cosine of y. It's always the same. But since I took the derivative of y, I need to write y prime. I'm going to get all my y primes onto the same side of the equation. I do that so that I can factor out the y prime. So I'm taking out the y prime so that the y prime is alone, and I can divide both sides by y prime. So 2x over 2 minus cosine of y is y prime. So again, the question asks, show that the slope is defined. So this is going back to trig a little bit. 2 minus cosine of y is never equal to 0 because cosine always fluctuates between 1 and -1. Do you remember that? Cosine graph looks like this. It goes up, it starts at 1, it goes down to -1, up to 1. So you never have to worry about it being equal to 2. If I add the cosine y to the other side, cosine's never equal to 2. So that denominator is never going to be equal to 0. So we just showed that it was defined. Next one. Oops, I don't want that. No. Okay. Find the tangent and normal line. This is a great question for skipping all the way down to the bottom and writing the answer because it's going to be a little bit long. Notice that a lot of times they'll do this. They won't actually write find the equation of the tangent line. Just find the tangent and normal. This really means find the equation of the tangent line. But just like you guys don't say picture, you just say, oh, let me see your pick. Like it's a pick. This is find the tangent. They really mean find the equation of the tangent line. So the tangent line will be y is equal to some slope times x minus, and look, they already gave me the point. I'm literally halfway there, plus 2. And then the normal line is also going to go through that point. Y is equal to blank times x plus 1 plus 2. So really all you need are the slopes. So this is a big fancy way of saying find the slope. So again, you can try this on your own. I will tell you that the two answers are 4/5. And of course, normal will always be negative reciprocal. So if you'd like to do this one completely on your own, that would be fantastic. Okay, if you tried to do it on your own and came back to the video, I'll just alert you to the two most common mistakes. The first one is failing to use product rule. And the second one is remembering to use product rule, but then forgetting to distribute the negative. So those are the two common mistakes. You can look back at your work and see if that's what you did if you're just joining us now. All right, derivative, 2x. I'm going to do the product rule. So the second times the derivative of the first plus the first times the derivative of the second, which is a y, so it needs the y prime, plus 2y. This one also needs a y prime. And actually, another place that people often go wrong is they write 7, but the derivative of 7 is 0. Very common mistake. So I'm just going to distribute my negative and simplify that a little bit. I'm going to keep doing my y prime in a different color. I don't know if it's actually helping anybody, but I like to think that it does. My y primes are already on the same side, so I'm going to factor out the y prime. And I hope I'm not going to throw anybody off here. I'm going to reverse the 2y and the x because I just think it's a nicer way to look. And in the same step, I'm going to move the 2x and the negative y to the other side. So I did like 4 things in that step, but you are in calculus, so think about that. For these two, I factored out the y prime, I reversed these, and I moved these two to the other side. That way I can have y prime is equal to y minus 2x over 2y minus x. If you did yours on a different side, you might have y prime is equal to 2x minus y over x minus 2y. That's the same. So if you just took my answer and multiplied the top and the bottom by -1, you would have that exact same thing. So don't think that it always has to be It has to look the same to have the same value. I'm going to switch my notation to f prime, but I need 2 points. I need 1 point. I need the x and the y, where a lot of times you just plug the x in there. So that's going to be 2 minus 2 times negative 1 over 2 times 2 minus a negative 1, which gives me 2 plus 2 is 4, and 4 plus 1 is 5, which is the number that I put right in there. I don't have to do any more work for normal. Normal is a fancy way of saying perpendicular. So the normal line would have a slope of negative 5 over 4, negative reciprocal. You guys are doing great. Okay, again, if you would like to try this one on your own, this one is especially challenging. The second derivative is 2x over y minus x to the fourth over y cubed, which of course there's more than one way to express that answer. So they want the second derivative this time. So for second derivative, I have to get the first derivative first. So I'm going to start off with the first derivative. 6x squared minus 6y y prime is equal to 0. So y prime is equal to, I'm going to subtract the 6x squared from both sides, and then I can divide by the negative 6y. And I get x squared over y. That's my first derivative. Now, to do the second derivative, I need to use the quotient rule. So y double prime is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom. So the derivative of the bottom is going to be y prime all over the bottom squared. Now here's the tricky part. You can't leave y prime in your answer. So I'm just going to simplify that. I'm going to replace y prime with x squared over y. This is y prime. So I'm going to replace it. That way I only have x's and y's in my problem, not y primes. I can't have y primes in my problem. Okay, sorry, I gotta reset. That's too bad. Y squared. Okay, so how do I clear that fraction? I'm going to multiply the whole top and the whole bottom by y. The bottom is easy. On the bottom, I'm going to get y cubed. And on the top, I'm going to distribute that y. And when I distribute that y to the first one, I get 2xy squared. When I distribute the y to the next one, it cancels. That was the whole reason I chose to multiply by y. So I get minus x to the fourth. That is the second derivative. You'll see that for whatever reason, the book answer chose to write them separately. I'm not saying that this is a better answer. In fact, I probably wouldn't do this. But just so you know, there are lots of correct answers. So this one is also correct, even though I boxed this one down there. So here was the tricky step. This is the step that you need to know, is that when you do the first derivative, you're going to end up with something, but then when you do the second derivative, you're going to have the first derivative be in it, and you have to replace that with x's and y's. You may not leave first derivative in your answer. What is the domain of this function? Be careful. Y cannot be equal to 0. Okay, so domain just means any restrictions that there's going to be. And you can't have y be 0. Find the equation of the line. All right, so as soon as I see that, I think to myself, oh, I'm going to have this, right? X, oh, they even gave me the point. It's a beautiful thing. So in other words, what do I need to know? I just need to know the slope at pi fourths comma pi halves. And then for the equation of the normal line, this is the exact same problem. So y is going to be equal to, I'm going to just have to do negative reciprocal. So number 8 is pretty much just another answer. X minus pi fourths plus pi halves. If you're attempting this on your own, then I'll just tell you right now that the slope comes out to be 2, which means this slope comes out to be negative 1/2. Negative 1/2. So there's the two answers if you want to try and do it on your own. But we will do it out. So if you got it wrong and you're just returning to the video, the most common mistake is not using product rule. So we have the second times the derivative of the first plus the first times the derivative of the second. So the derivative of sine of 2y is cosine of 2y. The 2y doesn't change. Then times the derivative of the angle, which is 2y. And the derivative of 2y is 2, but then because it's a y, we have to write y prime. Very challenging. But don't worry, we're going to do it again on the other side, so you get a little chance to practice. Now product rule again. The second times the derivative of the first. The derivative of y is y prime plus the first times the derivative of the second. So the derivative of cosine is negative sine of the same angle. Never change the angle. But then multiply by the derivative of the angle. The derivative of 2x is 2. It doesn't need an x prime like the y does. So interestingly, our next step would normally be to get the y prime alone, which would be a lot of work. So if you don't need the derivative, so the problem never says what is y prime. So if you don't need to actually find the derivative, if you just need the derivative at a point, plug in here, or I should say plug in now. In other words, no one's saying what is the derivative. You don't have to write it as a nice little y prime is, not needed. They just need to know the equation of the tangent line, which means I just need this number. So I'm going to go ahead and plug things in now. So sine of 2 times pi halves times 1, which I don't need anymore, plus x times cosine of 2y. So 2 times pi halves times 2 times y prime is equal to cosine of 2x pi fourths times y prime plus, actually I'm going to move the minus to the front, minus y pi halves times sine. Remember, I've already taken that negative, I've used it. Minus 2 times, let's get rid of that out of the way, sine of 2 times x pi fourths times 2. Now be careful, this goes together. The 2 is separate. It's sine of 2x. So this is really sine of pi halves, and sine of pi halves is 1. So this is negative pi halves times 1, and then times 2. This 2 doesn't cancel with this 4. It's separate. I don't know if you want to do that. Same thing here. This 2 is separate. That's cosine of 2 times pi halves, 2y. And this one I could put it around, but it doesn't really matter. So this becomes sine of pi, which becomes 0. Oh, that's nice. Plus this becomes cosine of pi, which is -1. Cosine of pi is -1. So now I have pi fourths times -1 times 2 times y prime, which becomes negative pi halves y prime. Oops, I'm going to just keep the color red for you. Y prime is equal to, this side becomes cosine of pi halves times y prime, which is, cosine of pi halves is 0. Oh, that was nice. Because 0 times that is just going to cancel that out, just like this 0 got canceled. And the last one, pi halves times the 2 is just pi. So y prime cancels there, and then I get just negative pi on this side. I multiply both sides by -2 over pi, -2 over pi, and I get y prime is equal to, the pi's cancel, and I get +2, which I then put in there, which you already saw only because I was giving the answers to people that wanted to do it in advance. And then, of course, normal means I take the slope equal to 2 of the tangent line, and the slope is going to be the negative reciprocal for the normal line. And that's what went in there. Okay. This is a lot of trig. It's a lot of trig. It's a lot of algebra. It's a lot of keeping things straight, realizing that this goes together, but the 2 is not part of that until you multiply at the end. Really challenging problem. So good for you for hanging in there on that one. Okay, the next one is actually just challenging at the end. So you're welcome to try it on your own. This is a challenge. I actually, if we were in class, would award extra credit for figuring it out. But at home, unfortunately, you can just look it up online. So no extra credit, but personal satisfaction, right? So if you would like to see if you can get that answer, you go for it. All right, let's do it together. So find dy dx. So first I want, that's y prime, and d squared y over dx squared is y double prime. So 3x squared plus 3y squared, I'm taking the derivative of a y. I'm going to add my y prime. Common mistake is to write 7. The other side is 0. Y prime is equal to, I bring over the negative 3x squared. And then I divide by 3y squared. And I get y prime is equal to negative x squared over y squared. Now I can do second derivative using quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom. 2y, and then because I took the derivative of the y, I have to write y prime. All over the bottom squared. That gives me negative 2xy squared plus 2x squared y prime all over y to the 4th. Remember from an earlier example that you cannot leave that y prime in there. Oh, I forgot to change its color for you. I cannot leave that y prime. So I'm going to replace it with the y prime that I've already figured out. So I get negative 2xy squared plus 2x squared y times, so what is that being replaced with? Negative x squared over y squared. All over y to the fourth. All right, I'm going to simplify that to negative 2xy squared plus 2x minus 2x, there's a minus there, minus 2x to the fourth, and one of those y's cancels with one of those, so there's just one y left on the bottom. I need to clear the complex fraction. This is not allowed, so I multiply the whole top by y and the whole bottom by y. As long as you do it to the top and the bottom, it's allowed. The bottom one is easy. I just get y to the fifth. The top one, I do have to distribute that y to both of them. Now, obviously, when I distribute it to this one, it cancels. That was the whole reason I did it. But on the other one, you are going to get negative 2xy to the third minus 2x to the fourth. So I would accept this answer. This is a good answer. The challenge in this one is figuring out how you got the answer that I stated right in the beginning, that negative 14x over y to the fifth. Again, if you would like to stop the video and challenge yourself and see if you can figure that out, it is a little bit of a fun puzzle, but not everybody likes a puzzle. So I'm going to tell you what it is. And that is, if you factor out the negative 2 and one of the x's, you'll be left with y cubed plus x cubed. And if you look really hard on your paper, somewhere it says what x cubed plus y cubed is equal to. Right there. So this becomes negative 2x times 7, which gives you negative 14x. Don't worry, I do not expect you to think of this. Like I said, this answer that I put in the box is good. You can totally stop there. But AP, if it's a multiple choice question and they go all the way to here, you could be wondering how they got that. And so you need to be thinking about that. Okay. All right, we have two more. Number 10 is actually just a thinking question. So it says, why is the derivative the same for both x squared plus y squared is equal to 5 and x squared plus y squared is equal to 7? Algebraically, it's because when you go to take the derivative, the 5 and the 7 are both going to go to 0. And so it really doesn't matter what the number on the end is. Graphically, they're circles. So one is a circle with radius 5, and one is a circle with radius 7. Actually, square root of 5 and square root of 7. And so at any point on that circle, you see how it has the exact same slope? It doesn't matter. It doesn't matter that it has a different number there because the derivative will end up being the same. All right, last one. The line that is normal to the curve, remember that means we're going to do perpendicular to the tangent, which is what the derivative always gives us. The derivative always gives you the tangent line. So just to go back to my circle for a second, just because it's already a picture there, this would be the normal line or tangent line. That's what the derivative gives us. Normal would be this one. So the normal to the curve x squared plus 2x minus 3 at 1, 0 intersects the curve at what other point? As you know, I'm a big fan of drawing it. So to draw a parabola, I personally like to factor. I feel like that makes my world easier rather than finding negative b over 2a, which is totally valid. You can do it that way. But I already know the y-intercept, and now I know the x-intercepts are negative 3 and 1. And I really don't care exactly what I know that this is the axis of symmetry, and I know that this is another point. Do I actually need to find the vertex? No, I just want a picture of it. So this is a great picture. So if I wanted the tangent line would look like that. It doesn't intersect again. It's following right along the line. But perpendicular, I'm not going to be able to draw this perfectly. Is that close enough to a right angle? So the normal line is going to intersect the curve at some other point. This is the point that we want to find. This is our goal. Okay? So your answer, when you box it, should be an ordered pair. So how do we find the intersection between a curve and a line? We need to know the equation of the line. So first, we're going to need the equation of the normal line. And then it's going to be algebra 2. We'll have a curve, we'll have a line, we're going to find the point of intersection. So what do I know about this line? I already know a lot. I know it has x minus 1 plus 0 as its point. I just need to know the slope. So my derivative is equal to 2x plus 2. I'm going to change it to the f notation. The derivative at 1 is equal to 4. So that means the slope of the tangent line, is equal to 4, which makes sense. It looks pretty steep. So that means the slope of the normal line is negative 1/4, which also looks right. It's down, it's negative, and it's not that steep. So if you want to, you can rewrite it as y is equal to negative 1/4 x plus 1/4. So now I have a line and I have a curve. I want to know where they're equal to each other. So I set them equal to each other. Where do they intersect? Oops, I lost my x. Negative 1/4 x plus 1/4 is equal to x squared plus 2x minus 3. All right, nobody likes the fractions. Get rid of the fractions. Whenever you have fractions, your first step should just be to clear them. Get rid of them. So now I have negative x, the 4 is cleared, plus 1, the 4 is cleared. And yeah, now I have a 4x squared. This is not the end of the world. Whenever I see an x squared in my equation, I set it equal to 0. This becomes 9x, and this becomes negative 13. And I factor. Now, I would normally try 2 and 2 first, but I don't know if you guys can see already that the 4 and the 9 make 13. So I'm going to leave it as 4 and 9 so that I can make negative 9x. And, oh, I want the 13 on the end. Oh, that was bad. So I do want the 4, and then I want the 13 and the 1 and the negative and the positive. So I can make negative 13. That was a terrible mistake. Minus 4x plus 4x is, nope, I want that to be positive. You can tell we're at the end of this video. Minus 1, so plus and minus gives me plus 9x. Which is so dumb. I already knew one of the answers, right? I knew that one of the answers was 1 because I knew it intersected at 1 and something else. So I should have known that one of my factors was x minus 1. So x is equal to 1, which we already knew. And the other place it intersects is negative 13 over 4. But remember, I'm looking for an ordered pair. So this actually isn't acceptable to stop there. As tired as we all are of this video, you can't stop at negative 13/4. You do have to plug it back in. Where you plug it back in is up to you. It's on both the line and the parabola. So you can plug into the line or the parabola. Plug into the line or the parabola. I know you're not doing it. You're just waiting for me to do it. You're lazy. I'm lazy too. I have the answer right here. So let's just pretend we all plugged it in. None of us did it. 17 over 16. Whew. Long problem, long video. You guys were great. Thanks for hanging in there. The whole year, calculus is tough. You're doing a great job. Have a good day, everyone.